Rectangular loop has a sliding connector PQ of length L and resistance R ohms, and it is moving with a speed V as shown. The setup is placed in a uniform magnetic field going into the plane of the paper. The three currents I1, I2, and IR. Okay. So this R ohms and this R ohms are in series, right? So if they're in series, their equivalent resistance is R by 2. Sorry, this R ohms and this R ohms are in parallel. Their equivalent resistance is R by 2, which is in series with this R ohms. So the total resistance is 3R by 2. And the EMF generated is BMB, right? At this particular instant when the speed is V, the EMF is BMB and the total resistance is 3R by 2. So the total current flowing is EMF by R, which is BNB by 3R by 2, which is 2BNB by 3R. And this current is flowing through the sliding rod, which is I. It is 2BNB by 3R. Now, since this resistance and this resistance are same, this I gets equally divided in these two branches as I by 2 and I by 2. If you check the directions, I2 is in the same direction as I by 2. I1 is also in the same direction as I by 2. So we can say that I1 equals to I2 equals to half of I, which is nothing but BNB by 3R. So I is 2BLB by 3R. So option A is wrong. C is wrong. D is wrong. Option B it is.